How does backpropagation train AI models? Have you ever wondered how artificial intelligence models learn and improve over time? One of the key methods behind this learning process is called the backpropagation algorithm. This algorithm is essential for training artificial neural networks, which serve as the foundation for many AI applications, including ChatGPT, DALL-E, and Midjourney. Let's break down how backpropagation works in a straightforward way. The training process using backpropagation consists of two main phases, the forward pass and the backward pass. During the forward pass, we start by feeding input data into the network. This data goes through the input layer and travels through one or more hidden layers until it reaches the output layer. Each neuron in these layers performs calculations by taking a weighted sum of its inputs, adding a bias, and applying an activation function. This function helps determine the output, which then serves as input for the next layer. Finally, the output layer generates predictions, often converting them into probabilities for classification tasks. Once we have the predictions, we move on to the backward pass. Here, we compare the model's predictions to the actual target outputs using a loss function. This function measures how far off the predictions are from the desired outcomes. The difference between these two is known as the error or loss. Now, here's where backpropagation shines. It calculates how this error changes concerning each weight and bias in the network by using the chain rule of calculus. This calculation gives us gradients, which indicate how to adjust each parameter to minimize the error. Starting from the output layer, these gradients are sent backward through the network, updating the weights and biases layer by layer. By repeating these forward and backward passes over many training examples, the network gradually improves its predictions. This process allows the model to learn from the data effectively. In practical applications, backpropagation is what enables models like ChatGPT to generate human-like text, DALL-E to create images based on descriptions, and Midjourney to produce artistic visuals. The efficiency of backpropagation makes it a cornerstone of supervised learning in artificial intelligence. From an ethical standpoint, understanding backpropagation is essential. It reveals how AI models learn patterns from data, which can sometimes include biases. Being aware of this process encourages responsible development and deployment of AI, ensuring that models are trained on diverse datasets to avoid unfair outcomes. In essence, backpropagation trains AI models by systematically adjusting their internal parameters to minimize prediction errors through a cycle of forward data processing and backward error correction. This method is what enables the creation of sophisticated AI tools that we see today in language generation, image creation, and productivity enhancements.